Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in Junos. In this lesson, we'll be covering inter-VLAN routing. Since switch ports are layer 2 ports, they typically do not inspect or interact with traffic any higher in the protocol stack than at layer 2. In order for a switch to perform routing between VLANs, a layer 3 interface must be attached to the bridge domain, so the switch may interact with the traffic at layer 3. So let's take a closer look at the layer 3 interfaces. These layer 3 interfaces that are attached to a bridging domain, or VLAN, are called IRB interfaces, or Integrated Routing and Bridging Interfaces. These interfaces function almost identically to a physical layer 3 routed interface, though they are a virtual interface which does not correlate to any one physical interface on the device. Instead, it is a virtual layer 3 interface which may be attached to a VLAN to allow the switch to perform routing on that VLAN. In this illustration, the switch receives a frame on VLAN 10, which is destined for an IP reachable on VLAN 20. The switch has an IRB interface configured both in VLAN 10 and VLAN 20. Because of this, the switch is able to route the packet between the broadcast domains and forward it to its destination. If you are coming from a Cisco background, IRB interfaces are effectively the same thing as switched virtual interfaces, or SVIs, on Cisco devices, where the SVI is a logical interface that is accessible over any switch port that is a member of the VLAN the SVI is attached to. Now that we have a better understanding of what an IRB interface is, let's review where in our enterprise network that we would usually find IRB interfaces configured. Since the presence of an IRB interface also implies that the device is participating in layer 2 switching, IRBs will only be present at a layer where the layer 2 links are present. As we discussed in a previous lesson, there are two primary access layer architectures when it comes to switching. These are a routed access design and switched access design. In a switched access design, where the links between the access layer and aggregation layer are switched trunks, as opposed to routed layer 3 links, the aggregation layer is where inter-VLAN routing occurs. In a routed access design, the links between the access layer switches and aggregation layer switches are layer 3 routed links. This means that we would not see any VLAN tag traffic here, as VLANs would not be necessary to segregate traffic. These links would not connect to switch ports with the Ethernet switching family configured. Rather, these links would have the INET or INET 6 families configured. In a routed access design, VLANs do not span more than a single access closet, and therefore the IRB interfaces would only be seen at the access layer. In a switched access design, the links between the access layer and aggregation layer are layer 2 switched links. 802.1q tagged traffic is sent across here, and routing typically doesn't occur until the aggregation layer. With the exception of management traffic, if management access in your environment is in-band, you may have an IRB interface configured on your access layer switches on a management VLAN for the purpose of having management access to the device. So, to recap a bit, in a switched access design, we'd see IRBs configured at the aggregation layer. And in a routed access design, we'd see them configured at the access layer. Now, let's take a look at how to configure IRB interfaces. In this example, we have a switch with two IRB interfaces, one for VLAN 10 and another for VLAN 20. The IRB interfaces are configured very much like any other physical interface on a Juniper device. Here, we show the configuration of each IRB interface on the switch. This is configured under the Interfaces IRB hierarchy. We see on both IRB interfaces, we have very simple configuration. Just the iNet family and an IP address configured to allow the IRB to route IPv4 traffic. The logical unit selected for each interface matches the VLAN the IRB will route for. However, this is simply best practice and not a technical requirement. As it's only aesthetic, the unit number could be anything you choose. Simply configuring an IP address on an IRB interface, though, is not enough to allow the IRB interface to interact with traffic. The interface must also be associated with a VLAN. As we can see in this configuration example, under the VLAN's configuration hierarchy, the IRB interface must be associated with a VLAN as an L3 interface in order to route for the specified broadcast domain. In the Edit VLANs hierarchy, we enter the VLAN which the IRB should be associated with, and configure the L3-interface command, with the IRB interface logical unit that should be associated. Once associated, the IRB interface can then route packets on the specified broadcast domain. It should be noted that a single IRB interface cannot be associated to more than one VLAN. As mentioned up here, the VLAN which the IRB is associated with must have at least one operationally up member in order for the associated IRB interface to also be in an operationally up state. If no member interfaces of the VLAN are in an operationally up state, then the IRB interface will show as administratively up, but operationally down. Let's take a look at how that situation would present itself in the following slide. As we can see in the example here, we can use the show interfaces terse IRB command to view the administrative, operational or link, protocol, and address information for the two IRB interfaces we just configured. Here, we see that the link status of the logical units we created are both down, although the parent IRB interface is up. To see why the logical units are in a down state, we can review the output of the show VLANs command below. We do see that VLAN 10 and VLAN 20 are configured. However, there are no member interfaces added to either VLAN. This means that there are effectively no active member interfaces in either VLAN, causing the link status of our attached IRB interface to be in a down state. Now, let's take a look below to see how this changes when an interface is added to the VLAN and that interface's link state is up. We see that the link state of our IRB interface has changed to up as well. Now that we've validated the physical status of our newly configured IRB interfaces, let's review what effect this has on our routing table in the device. To avoid having unnecessary routing entries here cluttering our view, we've only run the command to show us routes with destination prefixes in the 10.1/16 range. Here we use the show route 10.1/16 command to view this information. We see both the direct routes and local interface IP address routes are present in the table, showing these routes to be accessible via the IRB interfaces we configured. Thank you for sticking with me through this lesson on inter-VLAN routing. I hope that this has been informative for you, and I would like to thank you for viewing.